Hello friends, I am Monica. I will be explaining about how actually web searching happens, how search engine works. Let's start with introduction to the web search. As we all know, web search is nothing but finding all the web pages that are relevant to the keywords that user specifies. Naturally, it is not possible to find all the pages or to know if one has retrieved all the pages. Therefore, search is performed on database of web pages that have been collected and indexed. As we know, we get multiple pages that are relevant to our query. These pages are presented to the user in a ranked order relevance as determined by the search engine. Now we will see the generic architecture of search engine. This diagram shows various components of search engine. The first is www, the World Wide Web. It is information space where we access our websites or resources over the internet by specifying the URL. The next is a crawler. There are many crawlers shown here in this diagram. Web crawler plays most crucial role in a web searching. It is a program used by search engine to scan the web and collect data about web pages. The crawler retrieves and parses the page corresponding to the URL, then extracts any URL in it and adds this URL to the queue. In a next cycle, crawler extracts URL from the queue based on some order and retrieves corresponding page. This process is repeated until crawler stops. The next is control module. It is responsible for deciding which URL should be visited next. Then the page repository. Retrieved pages are stored here. Then indexer module. It constructs indexes on pages downloaded by the crawler. The indexes can be of two types, text index or linked indexed. Next is ranking module. It stores the large number of results and so those that are considered to be most relevant to the user's search are presented first. Then query engine. It evaluates the user query. The next topic is web crawling. As we seen earlier, crawler scans the web on behalf of search engine to extract information about visited web pages. It is impossible to crawl entire web because there are some limitations. The size of web is very huge. The web pages are changing in nature and the limited computing and storage capabilities of crawlers. Thus, crawler must be designed to visit most important pages before others. But there is a issue with visiting pages in some ranked order of importance. We will see this limitation one by one. The primary goal is to access more important pages before others. So there needs to be some way of determining importance of page. This can be done by means of measures that reflect the importance of given page. These measures can be static or dynamic. Static measures are independent of retrieval queries and dynamic measure takes the queries into consideration. The one example of such measure is PageRank metric that is used by Google and other search engines. The PageRank of page PI, which is denoted by R of PI, is simply normalized sum of PageRank of all PI's backlink pages, denoted as BPI. Formula is shown here. The rank of page PI is equal to summation of PJ that belongs to BPI rank of PJ divided by the mod of PJ. This formula calculates the rank of page based on a backlinks. The backlink is the number of pages that point to the P. The second issue is how crawler chooses next page to visit once it has crawled particular page. The crawler maintains the queue in which it stores the URLs of discovered pages. Thus, the issue is one of ordering URLs in this queue. One possibility is to visit URLs in order in which they are discovered. This is known as breadth first. Another alternatives are to use metrics that combine ordering with importance ranking, such as backlink counts or page rank. The next topic is indexing. The number of indexes are built to the efficiently search crawled pages and gathered information. There are two important indexes: structure or link index, text or context index. First, we will see the structure index. It is based on graph model with the graph representing structure of crawled portion of web. It can be used to obtain important information about linkage of web pages, such as sibling of page. Next is text index. It is most important and most widely used index. Indexes to support text-based retrieval can be implemented using any of access method traditionally used to search over text document collection. Example includes suffix array, inverted files or inverted indexes and signature files. Inverted index is a collection of inverted lists where each list is associated with particular word. Thank you.